what this this is for MET 284. I am Stephen Sutton. My cameraman currently is Levi Glass. I'll be explaining the code later. This is the game, The Bombardier. Now, this game is designed to work where you would press the start button to allow the game to begin. We would feed a ball into the carriage, and the carriage will have an electromagnet here, which will be into the loading position, which would catch the ball. And then with the game started, and the PLC would have a pot for analog input to tell the difficulty, which would actually set the timer that after you press the fire button, will then start a timer, which would then drop the ball. And then during that time frame, the carriage will continue to go back and forth, increasing the difficulty. Now the ball at the same time, once the game is started, the PLC will randomly pick a number to select one of the targets, and that will become your active target. So the idea is to time it to where the release will drop through whichever required obstacle chute, and then through the chute which has the target. Three successful hits is a winner. You get 2 chances. Then once you lose, it restarts to 0. As far as sensors, we have 7 targets, which will be AC. We have 7 to be exact, target sensors. So these sensors are AC sensors. And we have these because these are very abundant and useful. They're also larger, which made it easier to catch the ball because our lanes were kind of big. Then we would have one more AC sensor up here, and this will detect the ball. So that way the game knew that the ball was loaded. And then there'd be 2 of the PNP DC sensors to actually detect the carriage. So as the carriage would cross the sensor, it would know to stop the carriage and to move it to the other direction. While in the loading position, it would detect that when the game was over or the ball had been dropped, that it would return the carriage back to the loading position for the next ball. The carriage was used using a DC motor, a pre-designed pulley system which came with the motor, the guide rail that came with the motor as well. We took the carriage for a printer head, took it apart and modified it to allow the electromagnet to hold it, which electromagnet is a 12-volt electromagnet. Has 180 newtons of holding force. That was well enough to hold the ball, so that worked out pretty well. The build itself was practically complete. The hardest part was finishing the carriage and then pulling out getting everything wired together, which we were not able to complete. We do have all the sensors together. We have everything together to complete it. We just haven't gotten that far yet. I guess we'll go ahead and check out the rest of the wiring. So we can see that we already got the wiring here. We have our voltage dividers for the LEDs. Because the only thing we had, the easiest thing we went with was the power supply off the PLC here. So we went ahead and did some voltage dividers to get our about 3 volts in. So that way we get nice bright LEDs, but wouldn't blow them out. Here's our pot that we had to control our difficulty. Yeah, I think that's pretty much it as far as build goes.
Okay, as for how the points are going to be earned, if target 1 is the goal, which is the output for the targets is these LEDs here, and the input would be these sensors here. So if the target that is the goal lit up by the LED has that same sensor being tripped. So if this light is on and the ball goes through here, it goes to a memory bit, which will further on down the line add a point. But if just any target, if any target is hit and an LED is on, so if this target was one that was hit, but it was this LED that was on, it would just sense that a target has been crossed through, and it would have to wait for half a second without receiving that memory bit from up here that it was actually adding a point. Now, after each target is hit, it will select a new goal, which is what this code here does. It resets what's already been set. And the point system here, for adding a point, you have, if it's C1, which was the adds point memory bit from earlier, it goes up to this set point counter, which goes all the way up to 3. I don't know if you can see that very well, but it goes up to 3, so which it uses a bit system through an LED like this, and if it goes up to 1, if this CTD equals 1, it'll go through as long as these two conditions are also true. And going up to point bit 1 on. If CD2, if the count here equals 2 or 3, the bit number 2 will also be on. But if it equals 2, right here, this does not equal, so neither of these conditions will be met, so it'll be 0, 1, 1, 0, 1, 1 is what it will look like for the points. And the strikes are set up very similarly, except that it doesn't go all the way up to 3. And once someone has earned 3 points or 2 strikes and the ball is detected in the carriage, it resets the score for the next round that someone plays through it. As far as how the project goes and which parts are done and which part was the hardest, we managed to get the coding done first. Actually we managed to have the rules and such set up first. And then we got the coding done. We went to work on the physical build, which is this right here, and the physical build on the coding is not entirely done, but we've made a decent bit of progress. The next thing we really were working on was the wiring, which is all this stuff back here, and I feel like if we had more time we could have got the wiring to work properly, but there was time constraints, and so we didn't have enough time to do that. But the wiring should have mostly been handled in the coding here, which is in the PLC program. I think that's good.
Alright, so that was the Bombardier. We believe it would have been a pretty fun game if we actually got it working. We did learn a lot of skills from it. Program especially, that was quite difficult. The building part was only difficult because of the labor itself. Tools were difficult to come by. End of the semester, or the first half of the semester made difficult as people had other projects as well. But all in all, it was a fun project. We learned a lot. Enjoyable. Wish we could complete it, and might try to complete it by this semester if we have time. So thank you so much. Enjoy.